Well, good afternoon, good morning, wherever you happen to be. My name is Jauch, and I'm a product manager here at HashiCorp. Very excited to be with you virtually. As I'm sure as everybody's been saying today, we're really bummed out that we're not with you live, but we're going to give you our best show anyway. Cody will be with us a little bit later, and I'll let him introduce himself then. So hopefully everybody got a chance to see the keynote and talk about what's going on with HCP and our current and future plans. Something we're working on for a while, about a year now. So obviously we are very excited to have you all see it for the first time. And this is a very momentous occasion for the company. This is a chance for us to launch an entirely new platform, a new set of services, and really a new initiative into the market. So we're hopeful, and we hope you enjoy it and give us feedback and let us know what we're doing wrong, what we're doing right. There's a big team involved in making this happen, and all of us back home are still very focused on getting it ready. So it's early days, but there's a lot of potential here. So just to kind of repeat some of the core themes here, we really want everybody to understand that the goal here for HashiCorp is to help you have this multi-cloud experience. And I know that everybody, you probably hear this term a lot, and it's almost become a cliche already. But I think what most of my customers are telling me is that, yes, it's clear that multi-cloud makes sense, or I have aspirations there, but it's not super practical. When I build an application, I'm really consuming the underlying services, and it's quite difficult to move things around. And so one of the things that we're finding is that tools like Consul and others that abstract you from that core infrastructure really do support that type of mobility and help you build that long-term vision. Now, obviously, you're not going to start on day one, running all clouds all the time. That's not really what this is about. This is about helping you find the cloud that you want to run on, making sure that we're ready to support you on that cloud. And then as you grow or as you evolve, that you have that mobility and interoperability that you need. So that's the vision. And it was really great listening to Mitchell and Armand talk about that this morning. And I think that is a really compelling vision. It gets everybody here at HashiCorp really excited. I think the other thing that's important to note here is that when we talk about the cloud platform, what we're really talking about is a managed single-tenant environment, which is a little bit odd. It may not be what you're used to when you think about a SaaS platform. And what we mean by that is that the implementation of the way Consul is deployed is going to be completely isolated from other customers. This can be super important for some use cases. If you have regulatory or other requirements to ensure that you have very, very strong data integrity, this platform allows you to do that because you're completely isolated from all other customers. The other thing that it means, it might not be super obvious, but what it means is that you can have exactly the same API running in the cloud that you have running on-prem. So when a new version of Consul comes out, that version of Consul will appear in the cloud service, just like it does in the normal download sequence, and you'll receive those new features, and those features will work exactly the same way because of the same bits. So that's a little bit different than what we chose to do with Terraform. But when we talk to customers, one of the big things that customers really wanted us to do is they wanted to make sure that we had high degrees of interoperability between, say, open source Consul or the enterprise version of Consul and the service version of Consul. And this approach allows us to do that. And what you'll see is we'll repeat this theme as we go forward with other products on top of HCP. So we are going to speak a lot about Consul today, and that's on purpose. Just because that's the thing that's coming, and that's the thing that's ready to show you. But keep in mind that these are general themes, right? The idea is that all of our products, as they show up on HCP, will have this common kind of push button deployment method. They'll have a fully managed infrastructure. They will have this multi-cloud workflow that works across clouds. So these are common themes that we're building towards over time. Naturally, this will take us a little while. This is not instantaneous, but that's where we're headed. So what do we mean by multi-cloud workflow? What we mean is that the networking itself is going to be highly abstracted. We refer to this as the HVN. And as you might have seen in the demo earlier, we actually manage the HVN as a separate construct away from the cloud and abstract it away from the cloud. Now, of course, it has to relate back into actual infrastructure. And so there's a mechanism to do that. But the idea is that these HVN constructs will allow us to be consistent across clouds over time. It also implies that our organizational model has to allow for multi-tenancy, right? And so we're going to have a very easy way for customers to create tenants across their organization, across their clouds. The structure we use for that we refer to as organizations. Within that organization, you may also have multiple project teams because you might have a very large organization. And so we have this notion of projects. If you use GCP, for example, it should be very similar to the way GCP uses projects. Finally, we have to have RBAC. We have to have a way to ensure that the people in your organization have the correct level of access. Now, this might seem obvious, but we want to make sure that as you move into the cloud, we're ready to scale with you. So building a system for one developer is relatively straightforward. Building a system for 10 or 20 or 10,000 developers is a little bit more complicated. And so when we built the system, we wanted to ensure that we could scale to the largest organizations. And you'll see that those structures are there from day one, built into the product. That leads us to reporting. Obviously, if you have lots of people involved, you want to have a rich reporting experience. So all of these things are built into the platform, and they'll be common across the different implementations. So just switching back to Consul, since that's what we're talking about today primarily, I just wanted to note, because it didn't come up this morning, that the core bits, the core platform that we're using here is common between the Azure implementation and the AWS implementation. So we refer to the Azure implementation as HCS, or HashiCorp Consul Service. And you may have seen that beta. We announced it a little while ago. If you are an Azure customer, I would strongly encourage you to take a look at that because it allows you to get this Consul service in an Azure context. This is in public beta right now, and you can see there's a link there to it. But the reason why I bring it up in this context is that it is the same core platform. It is the same core bits. And so you're already seeing this commonality today. The way you buy the product is different because HCS is an Azure Marketplace application because that's what Azure customers want us to do. Whereas in AWS, it's an HCP application, so it looks different, it feels different, but it's still there. Obviously, the big news today is the fact that we are announcing the beta on the AWS side. So that's really exciting for us because this is our first beta on the AWS platform with these bits. And then, of course, the other thing we announced this morning is that Vault is coming as well. We didn't really discuss it in the keynote, but it's important to note here that Vault experience will be similar to the Consul experience, and it'll sit on the same core platform. So when I say platform, what do I mean by that? What I mean is that we built a system that allows us to manage applications across multiple clouds in a multi-tenant, in a secure way. And this diagram is trying to show us what that really means. So what we did is we built this Azure Managed App, which is sometimes referred to as AMA, and that's in gray there. But in order to implement it, what we did is we built the services in blue. So we have a core HCP services, which has API endpoints, it has workflow management. It's very closely integrated with Terraform because Terraform actually does the deploys for us. And that core code is common between the AWS version and the Azure version of the product. Underneath there, we had to build specific API services to make Consul work. And so as you can see this little dotted line here, this shows us the things that are Consul specific. So that what that means is that when we deploy Vault, the rest of the platform will be reused and we'll just implement those underlying API services. Similarly, down at the bottom in gray, you see the Azure implementation and then you see the AWS implementation. So there is code that's specific and unique to AWS in this HCP beta that we're bringing to market, but the core platform is common. And we just wanted to point that out that we're already on this journey to multi-cloud. We're already on this journey to multi-product. You're just seeing the first implementations of this now. So what are we really delivering in this beta? Well, we should really think of this as an MVP, right? This is the minimum viable product that we're developing right now. It'll obviously grow and evolve over time. We have a lot of investment in this space. We have a big team working on it. At the very beginning in beta, we're focused on a single region implementation. We are multi-AZ by default. And what that means is when we deploy Consul, we deploy the Consul cluster spread across multiple AZs because this is an AWS best practice. We don't have our own security constructs. We don't have our own routing constructs. We consume those constructs from AWS. So if you're already an AWS customer, hopefully this will be very, very familiar to you. The idea here is that when you install, or not install, when you provision Consul on AWS, we will use our VPC to provision all the assets that you can consume, that you can use. And so what that means is that the VMs or other objects running in your VPC won't be visible at all. And so what you'll have to do is you'll have to create inside of the AWS console a security group for us to use in common. Again, if you're an AWS user, hopefully this is very simple. You already have done this many, many times. But just to review, what that means is that you will have to create a security group that allows your assets, your VMs, to talk to our VMs, right? And once you've done that, then the idea is that they will be able to consume the console services just like they would consume services being presented in another VM. Of course, we are in a peered VPC situation. That is to say, our VPC is peered with your VPC. And that also implies that we're going to have a routing agreement between the two. The reason why we chose peering is because peering gives us the most flexible communication between your VMs and our VMs, or your EKS cluster or Fargate or whatever you choose to deploy. It's super important to note that Consul assumes a flat mesh network. Consul sits on top of a peer-to-peer system, and so all of the clients you deploy inside the data center, which is what Consul refers to a group of compute as, the data center hosts and servers must be able to talk to all of the clients. And so what that means is you'll have to enable full mesh routing for every single one of the VMs that want to participate in the data center. The easiest way to do this is just to create a routing group that includes the Consul servers and then add your VMs or others to that routing group. That's the easiest way. Now, obviously, there's other requirements, other more complicated things, but that's the simplest way. And then what you can do is you can create a route into our managed VPC using the CIDR range that you delegated to us at Bring Up. Just a quick note, we've had some questions in the past, are we going to support private link and other things? It's super important to note that the Consul, because it's expecting a flat network, does not really well suited to things like private link, because private link sits behind a load balancer. And so that's why we chose peering, VPC peering, because it was the most applicable way of doing it, and a way that we can guarantee that we had that connectivity that we needed in order to form the data center and make sure that all the members of the data center could talk to each other. I'd say the final step here is that once you have you created the routing group, you need to make sure that the target for the routing group is the CIDR block that you have delegated to us, and then you need to add that the route in the routing table. Once you've done that, then the machines on your side will have a valid route into our VPC using that CIDR block that you delegated to us instead of. All right. So now I'm going to hand it over to Cody. So Cody is going to walk us through kind of what the heck do you do with this thing and what is it for, and he'll show you all the good stuff. Cody, over to you, sir.
All right. Thanks a lot for that handoff, Alex. Really excited to come here and talk about HashiCorp Consul on AWS today. So my name is Cody DeArkland. I do technical marketing for Consul. And we're going to step through some of the ways that we expect people to actually practically consume this platform. There's a lot of ways that this can actually be used in real environments, and a lot of ways that it makes sense to create a way of establishing consistent networking between different types of networks. Before we get started, let's jump into a couple of key considerations and some things we want to think about before we jump right into demo. I promise only a couple slides before we get into the good stuff. People leverage VPCs as a boundary point within public cloud. So these are ways that we separate things like maybe teams, different technologies. Some people even use it to separate different platforms within AWS. So knowing that these are consumed in different ways, it becomes really important, the part that Alex talked about around how we establish that VPC peering relationship. We understand that people are going to come with a number of VPCs into these environments, and coming in and saying, hey, just bind one VPC to this and shove everything into that VPC isn't very realistic, and it's not how people are going to consume the service. People could expand this beyond just VPCs and even into multiple accounts. Alex and I being on different teams within HashiCorp, we might actually have different accounts entirely, but we might actually want to subscribe to this central console service platform that we would actually use jointly in just different ways. Likewise, people will use console in different ways and consume different functionality out of it. So it becomes really important for us to be able to acknowledge the different ways that people consume this platform and create a welcoming experience for you to bring those different concepts into the product. We've also seen it as design patterns emerge and the way cloud native applications are developed. We see people expanding to, in the early days, you'd see these large, very small amounts of large Kubernetes clusters. But now what we're seeing is a more team-driven approach to Kubernetes environments. And we're seeing many small Kubernetes clusters be something that's very prolific inside of environments. So it becomes very important to have a platform that lets you bring those in a very frictionless way. Likewise, and this is one that really stands out to me, I came from a pretty heavy enterprise background, and legacy doesn't always mean old platforms, right? Legacy doesn't always mean that the thing being used isn't a modern technology. Customers have spent a lot of effort to get into public cloud and consume some of these public cloud PaaS services, things like RDS, like I have in the following bullet. And we need to create an environment that lets people use that as part of the service mesh and bring that into console in some way as well. Finally, the big one that I get most excited to talk about is the way we handle application lifecycle. Being a little snarky, we sure talk about service mesh a lot. We sure use that phrase a lot, but ultimately what matters the most is applications. And ultimately what matters most is how applications are lifecycled inside of an environment. Why do people deploy infrastructure? It's to put applications on. Why do people connect these things? So applications can talk to each other. Why do people run things? So that applications come up and running. Applications really are the first-class citizen inside all of this. And lifecycle is something that really can only be done elegantly within a service mesh. So we're going to touch on that a little bit inside of this presentation as well. Jumping forward, we see a couple of kind of trends emerge on common workloads we expect to live within HCP. Things like traditional EC2 instances. Consoles, one of its kind of biggest powers is the ability for it to be multi-platform, multi-runtime. So we create a really first-class experience to bring something like an EC2 instance inside of AWS into that service mesh. Likewise, we want to be able to, and I harped on this pretty hard, Alex talked about this quite a bit, we want to be able to have these workloads potentially span multiple VPCs. If Alex manages a team that builds the front end, I might build the back end, and we want to be able to have an environment and a platform that allows us to have those two things connect in a consistent way. And that key word right there is consistency. We want to be able to have it be something that's, whether you're on EC2 instances, Kubernetes clusters, Docker hosts, so on and so forth, we want a consistent way to consume network automation. That's what we target inside of HCP and consoles at large. And finally, Kubernetes, right? It wouldn't be a conference talk if we didn't talk about Kubernetes several times in it. So we expect people to have many Kubernetes clusters joined to these environments. We expect people to mesh services between those Kubernetes clusters. A typical architecture would be to keep applications within the same cluster, but how do you create failover scenarios? How do you create an environment that allows you to have a primary and a secondary and failover, or even a third and fourth, right? We do that inside of console really well. So cruising forward. So this is kind of a rough, just a picture and something to kind of get everyone thinking about when I start talking about these kind of modern environments, what that environment could look like. We have HCP on AWS living on the bottom, and we have these different VPCs attached on the top. Maybe one that has primarily EC2 instances, maybe another one that has purely Kubernetes clusters, something like AKS or Cluster API on AWS. And then finally, how do we have 8 VPCs that have both of these, and what does that look like? When we peer all of these together, to Alex's point, how we have these things talk in a very consistent way, again, hammering on that consistency. We do that through VPC peering, and we do that through our service mesh and how we allow the sidecar proxies to talk to one another. So what is our demo going to look like? We're going to log into the HashiCorp Cloud Platform, and I'm going to show you what the common operations within that platform looks like. I'm going to show you how to pull down configuration files, how to generate a bootstrap secret, basically how to get started with the platform in a very quick way. I'm then going to show you what the peering relationship looks like within the platform as well, how we take networks that live within different VPCs inside AWS and combine them with or peer them with the ones that live inside of HCP, or that HCP creates at least. Mostly just want to show you what that user interface looks like between the two. We're also going to show how we can bring EC2 instances into the console. So how do we register those? I have a jump host already set up that we're just going to show bringing that in very easily. And then we're going to get into the good stuff where we start to bring in these different EKS clusters into HCP and use them. And we're going to spin up some traffic routing and see how we can split traffic between multiple of those environments. So it's demo time now. We're going to jump in. I also like to call demo time the time where I apologize for how high my cloud bill is this month. So we're going to jump over and get started. Here we can see the HashiCorp Cloud Platform logon screen. So if I go ahead and hit sign in, you can see that I'm prompted to log in with my GitHub account. So we have GitHub authentication set up against it. So if I hit log in, we can see that I'm brought into the HCP environment. I've already created my console cluster inside of here. So you can see these setup steps are already accomplished on the right. And if I go down to console, we can see that I've already deployed my cluster here. From here, I could download my client configuration, and really that's just a basic server config as well as the certificate that's part of the cluster. And I also generate my bootstrap token. We deploy this environment in a secure fashion by default, so ACLs are enabled and the UI is disabled. We're going to get into the UI a little bit, and that's because I've set it up for this demo specific to be able to show it, but it's typically not enabled, so pretend like it's not there, but you're going to see it anyways. We're going to click on this assigned network. This is the HVN that Alex talked a lot about. And we can see that I've created it on this network, and I've got an ID here. If I go up into my peering connections, you can see the different networks that are peered. 2 of them are active, and then 1 of them is not active. These are the 2 sets of networks that I have peered up. And if we jump into the AWS console, we can go down to our peering connections here, and we can see the currently active connections that have been set up. If we go into this third tab, this is the access to the UI that I set up that's typically not enabled, but I wanted to be able to show a full demo so you could actually see the configuration. If we go into nodes, we can see the different HCP nodes that are configured inside of this environment. So right now, if we go to the services view, you can see no services are currently registered. All we have is the console service in play. So let's think about how we practically start using this environment. Well, out of the gate, we need to be able to bring workloads in. So we know that things like EC2 instances and Kubernetes clusters are what's going to be used. I'm going to flip screens over and show a Packer manifest. This is a very easy way to get started building out access to the environment. That's how I do it for all of my demos and all of my presentations around these things. I'll build a Packer image. So it's very simple. Deployment here that will create an AMI inside of AWS that I can use to deploy EC2 instances that are automatically joined to the environment. Furthermore, I've done this to also allow me to deploy out a Nomad environment. So HashiCorp Nomad works inside of HCP as well. So this build is one. The other build I showed was one that just deploys a vanilla EC2 instance, but you can get all the way down to actually configuring workloads to actually run inside of the environment. So this manifest will actually go out or this Packer file will go out and build a set of images that will let me deploy out Nomad clients and servers inside of the environment as well. So in one hand, you can have a vanilla instance that allows you to just join and install, configure whatever applications you want on it, but you can also get down to actually configuring applications with it. I'm not going to waste your time showing building these out. These are already built inside of my environment, so we'll swap back to the UI and I'll show that. If we go into my instances view inside of AWS, we can actually go down to the AMI view and we can see the AMIs that I've created here. So we're ready to actually join a workload to the environment. Fortunately, I already have one built here. So what I'm going to do is I'm going to go ahead and start up the service. Starting this console service, but I'm also going to start the connect service, which is a console service mesh functionality. And now if I go in and do a console members, we can see that I'm actually in the cluster. I've joined, I'm a client node. and this is now available. Now, this server is actually going to focus as our ingress into some of our traffic splitting scenarios. So immediately we're going to need to have a service registered for that functionality. So if I go into my services view, we can see the ingress has been registered, and I have a sidecar proxy associated with it for allowing communication between the environment. You'll notice this UI looks a little different from some of the other presentations you've probably seen so far. This is still running on console 1.7. 1.8 has some updates to this, so you might see a little inconsistency there, but it functions the same. I have the ingress service already registered, and if we take a look inside of the UI, we can go to the console directory and take a look at that service registration. Service registration registers ingress on port 80. It's got the token associated with it, and it's telling what services it can talk to. So this is able to talk to the front-end service on port 80. By default, we have no intentions enabled inside of the environment. So while we have this service up, it's not going to be able to talk to anything until we can actually enable those intentions. So we're going to jump in, and we're going to get started deploying out the Kubernetes portion of our adventure. So I'm going to switch back into the UI. And I've got all of this kind of plotted out in a very straightforward way. So we'll start off with step 1, which is deploying out our first EKS cluster. It takes a few bits of input that I've already configured, the HCP bootstrap token, the encryption key, and the cert. These are all part of that bundle that I showed being able to download from within the UI. So we bring these in and we create Kubernetes secrets around them. So if I do a kubectl get secrets, kubectl get secrets, we can see those secrets have already been created inside of the environment. Now, if I do a kubectl cluster info, we can see information about this cluster. And we can go ahead and get started deploying this workload. I paused there because I have to check something to make sure that I actually use the right cluster. So let's take a look at how we can get started now going ahead and deploy. So if we do a helm install against our file 1, we can see I've ran this command before. We can see the cluster I'm interacting with on the right, and I'm going to hit enter and it's going to start to deploy. And what we'll do is we'll very quickly switch back into the UI, and if we go and take a look at the nodes, we can see those nodes start to come online in a few moments. So there's the first one, the second one, and the third one. So that's a 3-node EKS cluster that's been deployed. It's already finished deploying. And if we do a kubectl get pods, we can see that the server nodes are actually running, or the client nodes, I'm sorry, are running inside of the environment. So this is now joined to our cluster as a client. And in order to use that, we can go ahead and deploy an application. So I'll do our demo application. And what we'll see is this start to come online and start to run checks, as well as start to return services. By default, we can see that this is not connecting successfully right out of the gate, so it's going to take a few moments to finish updating. And we might see some error messages in the actual logs as those services come up. So let's get our pods and take a look. It takes a few minutes for it to come up and actually register. All right, so we can see our service is finally running, and if we go and look inside the UI again, we can see that the service has come up, and we have our connectivity between the environment. If we switch back, we can get the load balancer for that, which is right here. And we can see our application is currently up and running, but it's unable to connect successfully. We'll need to enable intentions to allow the communication to take place. So what we'll do is we'll jump back over to our jump box. We'll jump back over to our jump box. And we'll do console intention create front end to API. And in a few moments, we should see that connectivity successfully established. So we can see now that that's working, but our database connectivity is still not working. If we do console intention create API to DB, that connection successful as well. And if we go into console's intentions, we can see that connected as well. Now, this would be simple enough if this was just a single cluster environment. Now we have our service mesh up and running. We can see that the communication is happening successfully. But what we want to show is the ability to bring multiple Kubernetes clusters in and the ability to actually consume multiple levels of an environment. We're going to create one more intention before we get started. And that intention is to allow our ingress service to be able to talk to our front-end service. And this is going to be very important in a few moments here. So that intention is created, and I created that one through the UI. We also have the ability to create these via API as well. So we're going to flop back over to the CLI, and I'm going to switch now to a different EKS cluster. And we can see that this cluster is currently empty as well. This one does have a vault instance in it, and that's because I'm going to be using Vault to secure my secrets inside of my demo application. So just like before, we're going to use a configuration file that actually, that's the wrong configuration file, sorry. We're going to use a configuration file that takes in a set of information that we've already populated inside the Kubernetes secrets to allow this to join the environment. These are all part of, again, VPC networks and VPCs that have appeared with the HCP environment. So we're going to do a Helm install, and we're going to do this against EKS2 using the console Helm chart. And we'll switch back into the UI. We'll go to the nodes view, and we should see these nodes pretty quickly come online. So there's 1, 2, and 3. There we go. All right, so those came online. And if we switch back in, we can see that's been installed successfully. And we can see that our actual instance is up and running. So we now have 2 Kubernetes clusters joined inside of just inside of the timeless demo. We were able to add 2 EKS clusters to this environment. So let's go ahead and get our workload going. We're going to switch back to my other environment, and we're going to deploy just one arm of the environment this time instead. And you'll notice that I'm not taking down the existing application. So the existing application is currently serving traffic. People might be using it. So we're going to look at my files, and I'm going to apply the initial demo for site 1. So if I do, looking at the actual file, we can see I'm injecting the connect bits for allowing service mesh communications. I'm setting a version on the application, which is unimportant for this demo. I'm setting it to port 80, and I'm telling it to talk to the API service on port 5000. So I'm going to go ahead and do apply on file 3, which is going to create our front-end application. But it's creating a V2 of the application, as you can see. We can see that initializing right there. And in the interest of saving time, I'm going to quickly switch back over to the other instance and deploy the second part of this application as well. We'll switch back over, take a look at our files. Apply file 5, which is going to be our API tier and our database tier. And if we look through this file, we can see the database getting injected, which is a simple Postgres database. And then we're also bringing in a pod that has some of the Vault configurations to automatically inject Kubernetes secrets in. So what's interesting about this is we're using HCP, but I'm also able to bring in Vault as part of the EKS cluster and still use that against workloads. It might not be integrated with HCP right now in this case, but I'm still able to use that Vault Helm chart inside of the environment. So that's been deployed. If we go look at services, we can see we have a whole bunch of services in this environment now. We've got our API in place. We've got a couple of front ends in place. And if we switch back in kubectx to our primary environment, we can see that we have a load balancer deployed for the second one. But we're actually going to use our ingress to access this resource now. So we're going to switch back into our EC2 environment. We're going to grab the IP address for that ingress service. here. And I threw that on port 8080 just to be a little bit different. So this is now the ingress coming in. The ingress was allowed to talk to the front end, and we know that whole service all the way through is allowed to talk, so the intentions are allowed. But we're going to start doing a little bit of traffic splitting now. We're going to switch into our jump host. And if we take a look inside of this directory, I have a set of files here that allow us to configure this. I'll go ahead and bring these files up, and we'll step through at a high level what each one of these does. We're creating service defaults that tell it that these services are HTTP services. This is how we tell it that it's an actual web application that we're going to be able to split traffic against. We're then setting up a service splitter that is, in this case, telling it to send all traffic to the new service. What we actually probably want to do, though, is switch this back so that it stays going to the primary service and then show it flip to the new service. So I'm going to edit this file. I'm going to change this down to 0. I'm going to set this to 100. It's not 1000. That wouldn't help anybody. And we're going to apply these two files to console. So console config write 1, console config write 2. Oops. Got to finish that command. Console config write 3. Now, if we switch back into the user interface for console and we go and look at that actual service, for the ingress, for actually the front end, sorry about that, and we look at routing, we can see we have a router set up now that's routing traffic between these two environments. If I switch back and take a look at our UI, we should see that nothing has changed. It's just the same application that we had in place before. There we go. You should see the same application that we have in place before. And now we'll go back and we'll return that file to what it was before, 100% in the other direction. So we'll flip this to the version 2. Now, in a typical environment, you would want to gradually make this change. Since we're at HashiConf and in a whole different time zone, doing it digitally, we're just going to YOLO the change and allow it to go through to flip 100% of the traffic over. So that change has been made now. We can see that the connectivity is erroring because it's no longer connecting to this service. So we can see this error message has changed to this upstream connect. That's because I haven't set up intentions to allow the ingress service to talk to the new front end. This is how console keeps you safe by requiring explicit communication enabled when ACLs are turned on. So I need to go in and I need to turn on allow the ingress to be able to talk to the front end version 2 as well. So if I go into the intentions view, I can create a new intention here. I can say ingress is allowed to talk to front end version 2. Allow. And we're also going to set up our other allowed communication as well. Front end v2 talking to API. Front end v2 talking to database. And just to again save on time, we'll set up a future set of the configuration we're going to do where we allow the front end to talk to API v2 as well. So I'll do front end v2 talking to API v2. So we have a bunch of communication allowed now. If we switch back into here and we do a refresh, the application comes up and we're on our dark mode of our application. We're happy. We enjoy the darker theme of the application and our connectivity is allowed successfully. If we go in and we take a look at our actual API, we're able to reach the backend service, but this is an older version. It's not the version 2.0 of the API that we would expect. So we're going to do the same sort of traffic splitting between the API tier as well. So this is our old version of the API. So we'll switch back into the command line. And now again, if you do a 4, 5, and a 6, we can see we're doing roughly the same thing with an API tier as well. So we'll do a console config write on 4, 5, oops, and 6. Again, normally you would not shift everything at once. You would do it gradually, but for the sake of time, I'm going to go ahead and flip it over to 100%. We'll flip back, and if we hit refresh on the screen, we can see we're getting the version 2 of the API, and we're getting a little bit of a different message. So the API has been migrated now to the second Kubernetes cluster, but the front end is still, the ingress still lives as a VM, and we're now splitting the traffic between these two EKS clusters, and we can flip this back and forth as much as we want. This is a way that we can really enable something called progressive delivery, right? When you think about how we lifecycle applications and how we bring applications into the enterprise, we don't often want to do full flip over and instantiate just a whole new application and then change our load balancers, change our DNS to be this new application. We want the ability to come in, set up a gradual failover and a gradual path to actually migrating services over. And that's what we're able to do inside of Consul and Service Mesh. And especially when you look at HCP, with AWS being as big as it is, with so many different application types in there, people want to be able to come up with ways to gradually migrate services into a new environment, or be able to gradually fail over or set intelligent fallbacks to other environments. And the layer 7 traffic abilities inside of Consul really make it easy to do that. So just to highlight what we've accomplished so far, I've got one more trick in my pocket before we wrap up the demo here. We've gone in and we've deployed Consul, we've deployed 2 EKS clusters as well as a virtual machine. We have that virtual machine acting as an ingress for these services. We're setting up splitting behind them so we can actually fail traffic back and forth. We could go in and set these to 50-50 and bounce back and forth between, but I think you understand how this works so far now already. Finally, now what I want to show is how easy it is to deploy additional workloads from an EC2 perspective in here. We showed starting up the other service now it came online. Let's go ahead and deploy a couple of EC2 images real quick that will actually bring up Nomad inside of this environment as well. So we're going to go into EC2, and we normally would do this in Terraform, but for the visual, I wanted to show it inside of the UI. We're going to go into the AMIs, and we're going to use this Nomad server AMI down here on the bottom. So we'll do select. We're going to set this to 3 instances, not 31. We're going to change this to a specific subnet inside of the environment. Actually, we'll change this to a specific VPC as well. Go ahead and enable our externals. I think we're good. We'll hit review and launch. We'll use my existing key pair, and we'll launch the service. And in a few moments, we'll see this service come online. Actually, real quick, I need to go in and edit the security groups to give us appropriate access to the environment. So we can see those coming online. I'm going to quickly go in and switch the security groups. Again, all of this could be very easily automated using Terraform to include this all as kind of one shot, and it gives you a way to have it be a declared state inside of the environment. There we go. Those are all configured. And if we switch back into the services view, we can see that Nomad cluster starting to come up. Now, these are just the server nodes. I haven't deployed the client nodes. I could deploy those as well, but I figured it's easier just to show that we're able to bring that on. But we can see how fast, once we have an existing AMI that has all of the configurations for HCP in place, how easy it is to get workloads running. This demo's been going for about 30 minutes now, and we've already brought a virtual machine in, 2 EKS clusters, as well as stood up a Nomad server cluster inside the environment as well. It's pretty incredible when you look at how much value you can get very quickly inside of the environment. So that about wraps up the demo portion of this. I hope you've enjoyed what you've seen here. I'm going to hand this back over to Alex to take back over. So Alex, do you want to take it away and bring us home?
All right, thanks, Cody. That was an awesome demo. I really appreciate all that detail. Hopefully everybody got excited and energized about what this thing can do. I said it at the top of the show, but keep in mind that we're just getting started here, just starting to show the tip of the iceberg. So lots of good stuff to come. Please stay tuned. In the meantime, we would really appreciate your feedback, your input, and your engagement on the product today. We have 2 different flavors, as I mentioned. We have AWS native, which is the big announced today, and then we have the Azure beta, which we've been working on for a couple months now. There's the links here please do click through, give us your information, and we'd love to see you on the platform. All right, well, that's it for us today. Thanks a lot, and enjoy the rest of the event.
Absolutely amazing. Thank you very, very much to Alex and Cody. Really, really enjoyed that session. And now I'd like to welcome you both back for a live Q&A discussion. So welcome Alex and welcome Cody.
Hello.
Over to you, Dom, to take care of this Q&A session.
Of course, thank you. Before I ask the question to either Alex or Cody, I would also like to ask this to the audience. Please use the chat on the sides to give your answers. What does service mesh mean to you? What does it solve? Alex, could you start us off?
Yeah, absolutely. The really interesting thing for me about service mesh is how applications and systems are evolving over time. What we're seeing is that there's an enhanced complexity as microservices become more common. And that complexity then leads to issues such as connectivity and security and observability. And what we're seeing is that service mesh is a really interesting way to ensure that all of your various parts and pieces can talk to each other. And so the concept between service mesh is in some ways extremely simple. You deploy a service that has a certain set of APIs, you advertise those, you have consumer services, and then allows you to make this kind of brokerage between the consumer and the provider. So it's a very neat, very clean way to develop microservices. And what our customers are telling us is that as their applications grow in complexity, service mesh is a great way for them to keep that complexity under control and allow secure connectivity between the various parts of their system in production.
Yeah, makes a lot of sense. What about you, Cody? Same question for you.
Yes, similar answer. I think what's really interesting about service mesh is again, I kind of alluded this during the presentation that we throw this term service mesh around quite a bit. But when you focus on like the outcomes of service mesh and you focus on the things that you're getting out of it or the things that you're actually chasing, accomplishing, it's a pretty easy thing to digest at that point. The things like automatic MTLS encryption, things like being able to control traffic flows and the way you split traffic. You know, I mentioned progressive delivery, and that's something that James Governor over at Red Monk kind of came out with and pushed a few years back. But the only way to really achieve that within like applications is within service mesh and within using service mesh. So these like outcomes become like super important for why you actually go down that path and why you actually want to achieve a service mesh. It's about making the applications that we deliver and connect much simpler and easier to consume. But yeah, other than that, I generally agree with the same things that Alex said.
Amazing. Rob, did we get any audience feedback on this, or any questions?
Not specifically on the definition of a service mesh, but there are some interesting questions that's come in. So I'll just ask this one here, and this one is: will connectivity through transit gateways be possible in future, and how will peering be initiated? Will the HVN trigger it?
Yeah, so that's kind of two questions in one. So talk about federation first. So what's going to happen in the current version of the product is we chose to use the simplest networking model possible, which is peering inside of the VPNs. So the way the beta works is that you would trigger a peering connection from within the HCP portal. I almost said the console, Cody, so that's not good.
I do it so many times. I've done it so many times.
Inside the portal, there we go. You would trigger that peering relationship. And the reason why we did it that way is because it was the simplest way to allow connectivity. You'll also note that the Azure product, which we sometimes refer to as HCS, works in exactly the same way. So we have parallelism between the two versions of the product. TGW is a very interesting conversation. For those of you that don't know, TGW stands for Transit Gateway. It's a service by AWS. In effect, it's a little virtualized router. What it actually does is it gets presented as a virtual machine, and then that virtual machine then presents ENIs into the VPCs that you want to connect, and then there's a simplistic routing application built into that thing. So it's a little bit newer than peering. It's extremely powerful. It's also not free. That's a service that AWS charges for by the hour. So we would expect that customers that have larger or more complicated networking environments will eventually want to use TGWs. And it's definitely something that we are looking to support. But the current beta is focused on just the very simplest case, just to get us out the door. So the phrase that we tend to use is MVP, minimum viable product. So we want to make sure that we can host Consul in a meaningful way, running meaningful workloads, and then we'll add complexity to the solution as we go forward. By the way, if you are interested in the Consul service on HCP and you really want to push harder on TGW, please do reach out to us, either through social media or through your account team or through GitHub issues or however you wish to do so. Smoke signal works too, because we're actively recruiting customers who are interested in that feature, and we'd love to talk to you about that in detail.
Awesome.
Amazing. Thank you.
All right. So
we have another question.
Oh.
Oops, sorry, Dom. I just want to ask this audience question, if that's okay. So
No, that's fine.
could we use service mesh with traditional DC inside a single VLAN? What the difference between FW micro segregation?
This sounds like a Cody question.
Ooh. So this is one of my most favorites. So absolutely, and I think that my team and I, like when we talked about the Consul 1.8 launch that just happened, we talked a lot about this concept and this idea that like we've really started to frame this conversation about service mesh to be really specific to like cloud native applications and the next generation of computing, which it definitely lives more natively in that space. Like there's a fair statement there, but with Consul, we really focus on making virtual machines and traditional data center really a first-class citizen in the ability to participate in service mesh. So yes, you can absolutely use this within a traditional VLAN setup inside of an environment with traditional like SDN players in the marketplace and having Consul sit right on top of that. There is a slight overlap between like the intention-driven policy of Consul and what you'd see in typical microsegmentation. But there's also a very different approach there. Consul's focused on making service-to-service communication truly identity-based, right? So the idea of a front end is always a front end, whether its IPs are 22, 25, 29, and 30. All of those servers are a front-end server, and we know that those front-end servers should talk to API server, which might be, 52, 57, 59, and 60. And those IPs might change. In EC2, if you power on a powerful VM, odds are high you're going to get a different IP address, right? So like, in that case, a front-end service is always a front-end service, an API service is always a front API service, and intentions allow those to communicate. And that's why they're called intentions. It's the intention for the communication path between those two things. So there's a little bit of overlap from a microseg perspective in the way that SDNs typically approach that, but there's enough difference between what we're looking to accomplish in Consul versus those that it's not really an either or in that case. It really depends on the workflow you're chasing. If you're chasing like a zero trust networking policy, then maybe Consul is the better route for you to go for, because it is pretty simple to get intentions up and running. But it's a workflow question there, not necessarily a technology question.
Amazing, thank you. We have one more question, so I'll read this out. This looks like a great start, but I noticed that the secrets were all pre-baked. Is there a plan for properly managing root of trust versus baking AMIs and K8 files?
I think that was simply an artifact of the demonstration. Just to be clear, every Consul deployment is completely secure by default. We do not have public IP address. Root keys are generated only upon demand. And you have full access to create additional keys as you wish, just as you would do on-prem with Consul. what you actually saw on the UI there was a button to create a root key. And the reason for that is just expediency, just so we can make it work. Over time, what you'll see is that the console client itself will learn how to bootstrap itself into console. There's a little bit of detail here, but normally what happens on-prem is that you don't have a kind of a standard root of authority when you install the product, right? So there's a sequence of events you have to go through to, in effect, unseal and bootstrap the product. That's not the case here. We actually are using what's called a managed MSP token, which allows us to manage the console cluster on your behalf. So in effect, what happens is we delegate root access to you, and that delegation process will appear inside of console itself. And specifically, it's a post 1.8 release. So those bits are still in flight. So we have this kind of sidecar method right now. But over time, that'll just become a console feature.
Yeah, and just to unpack like the question a little bit also, like, yeah, there was definitely some pre-baked stuff in my demo, no doubt about that. But that, just to Alex's point, it was purely because of it was a demo, right? Like there's aspects of this that could have been made more dynamic and could have been made more like in a true secure fashion outside of a demo. It's really meant to show the ability to deploy some apps and get them meshing and get them and get traffic splitting set up between them. But it by the nature of making that a quick demo, there was aspects of it that were very quick. So it didn't have to be that way. And to Alex's point also, there's a number of features coming to help with this bootstrap process and the way we bring these systems online. There's big conversations that I had late last week around this very topic that are going to be some mind-blowing stuff that aren't that far away. So like just keep an eye out for things. One thing just to shout out real quick in a positive stance, like I'm seeing a lot of engagement on this conversation on Twitter also. I love the fact that people are diving in and having good conversations about this stuff now. It's really exciting for me to see this space grow. So thanks to everybody out there in the social media space for jumping in and having some good conversations about this right now.
Amazing.
Yeah, awesome. Thank you so much.
One last audience question.
Okay, fine.
Sorry, Deb. I just want to give the HashiCorp family a chance to talk to us. That's all.
Okay, fine.
Right, this is a really good one, actually. Right. So, will HCP hold any security attestations like PCI DSS? This sounds like an Alex question, I think.
Yeah. The answer is yes, absolutely. We fully intend to have the product certified. There's a couple of dozen, honestly, globally that we'll be working on, from U.S. federal government to PCI, HIPAA, and etc. The system was designed to be extremely secure and to pass the highest levels of attestation that we're currently aware of. Obviously, a lot of these programs are rather involved. You have to hire an auditor. The auditor has to go through your system. Usually auditors like to say something and have a few changes, just because that's how they get paid. But in all seriousness, yes, our intent is to do that. And what you'll see those coming out over time as the product evolves. At the moment, we're really focused on just the basics, making sure the product works, making sure that it's secure, making sure that it's stable. And then once we have all of those things in place, then we'll go for the exterior, all the hardware. You get a nice little certificate you can hang on your wall. So we have a place picked out in the office for those.
Great.
Amazing.
Great stuff.
Thank you very much. And
all right.
Over to you, Domi.
Yes? Are you sure? No, I'm kidding.
100%.
I've got a few more questions that I would like to fire off the gentleman's way. It may be a bit of a biased question, but when should one use a managed service for service mesh versus building your own?
Yeah, that's a super interesting question. A lot of customers ask me that question. I think the answer is a little subtle. We're working very hard to ensure that, like Consul, for example, as a managed solution, is similar to Consul as a hosted solution. So it's not really a technical answer per se, because in theory, you should be able to do the same thing. What we have found is that customers who go to cloud tend to be in the position where they would prefer not to operate their own infrastructure. They see that as low value work, whether it's worrying about patching or uptime or taking pager duty calls on a failed server. This is not core competency for them. They don't perceive that they're adding any value to their company. And so they'd like to outsource that work. So similarly to consuming a service like RDS from Azure, from AWS, consuming Consul as a service from us makes sense for those customers. Cody, I don't know if you have like some other views here, but to me, it seems like a customer preference largely, depending on how they want to operate their system.
Yeah, I think that like there's things you get when you artisanally craft a console cluster that you can get very deep into configurations, and you get very customized configurations on a line by line basis and tune things in a very specific way. But generally speaking, as a former operator, like I would rather just have the system manage itself, right? Like if at all possible, I'd rather use the managed service and be able to have the system manage its own uptime, have another group be responsible for keeping this up and running. And it generally comes to like a cloud consumption conversation, because a lot of the cloud platforms are that way. If I needed to bake things and be very like handcrafted around this, I would deploy it. In the case of AWS, I would drop it on EC2 instances or into a EKS cluster. But generally, if at all possible, I want to consume a service. I don't want to have to worry about, hey, did I set up redundancy zones and what's my backup schedule set like? If I can say that the managed service handles all that for me, that's all the better for me, because if something goes wrong, I hold HashiCorp responsible for it. I get to say, hey, where are those backups? Take care of that for me. So managed service where possible. If I need special compliance reasons and things artisanally crafted, I'll drop it on EC2 instances and roll that way.
Amazing. So I think the question that's on everybody's lips, where can people learn more about this? Cody, do you want to take this one?
Actually, I think Alex probably has been closer to the building of how to get started with this. So I'm gonna punt it to him instead.
Yeah, actually, we're taking signups for what we call private beta right now. There was a link in the main stream. You can also go to HashiCorp.com in the cloud section of the marketing page, and there's a sign up there. What'll happen is you'll get a prompt where you fill out a form. At the moment, the beta is by invitation only, is what we refer to as private beta. So we'll be bringing on a relatively small numbers of customers just to make sure that the system is stable and ready. Once we hit that stability milestone, then we'll open it up for public beta, and you'll be able to self-serve without being gated. But in the meantime, yeah, please do click through the links that was on the page. And I think we dropped it also in the chat. If not, I will in just a moment drop it in the chat. And we'd love to have you on the system and get your feedback.
Quick follow-up comment around that, not just about HCP, but in Consul in general. I don't think people always realize how easy it is to get started trying out Consul. So like if you're not somebody who can jump on and deploy this in HCP, and for some reason you can't get that going right away, or you need time to get into the beta, stuff like that, Consul is really easy to get up and running, to like give it a try and give it a spin in your own environments. Check out the Helm chart. Go and look at our Consul.io webpage. It was just redesigned. Look at the Helm chart. It's easy to get up and running, easy to get started consuming. If you want to deploy it on virtual machines, it's easy to do it there too. We have a great set of learn guides around it. Like, please go check it out. 1.8 drops some awesome functionality. We're really excited for it.
All right. Alex, Cody, thank you so much for joining us. I'm aware of the time difference at the moment, so I really appreciate you joining us today and answering the questions and for your great session. And I will be seeing you soon. Thank you very much.